You know, it's so funny, when I was a kid, when I was in like middle school, like it wasn't that cool to play video games. Like, I played video games, but it was like some kids were like, they like make fun of you for that. Like some of the too cool for school kids. And now it's like, not just like cool, it's like you can make money.
Yeah.
It's like totally changed.
You can make it.
Which, whatever, I think some video games are fun, and I think they're not all a waste of time, but some people spend way too much time playing them. But if you're going to make $500,000 a month, why not, I guess, right? I don't know. All right, moving on. It's just crazy. All right, always write out the reaction, because then you're going to be able to see mole ratios. I think if some of you lost points, it's because you didn't know the two here, because the question wants you to calculate ultimately the grams of this, so you need to know there's a 2 in front of that. So they give you the molarity and the volume of silver nitrate. So you get your moles of silver nitrate 0.0075. And believe me, I know it's hard, like you took this a while ago, but at least, you know, just try and pay attention to what I'm doing up here. So you got your moles of this, and now you need to figure out, okay, what's my mole ratio here? Oh, I'm sorry, I misread. We're figuring this one out. So it's a 2-to-1 ratio, so this number is half of that. And it must tell us that one of them's limiting. No, maybe not. Does it? No, okay. So again, I don't want to spend too much time. I'm just going to move on. But basically, if you have the moles of this, you can use the 2-to-1 ratio. So this number is half of that, which is 0.00375 moles. And now, to find the grams, you just multiply by the molar mass. So it's 23 plus 23 plus 52 plus 64. So you add up the molar mass, it's this number times 162, I want to say. Yeah. So that's grams per mole. Moles cancel, and that's how you get 0.6075. 0.6075 grams. That's how you do number 1. Number 2, same thing. You got to write out the equation. Now this one, it gives you limiting, right? Or it says it's completely consumed or something like that.
The molarity of both things.
For number 2?
Yeah.
Go ahead, read it to me.
Barium sulfate can be produced when 100 milliliters of a 0.1 molar solution of barium chloride is mixed with 100 milliliters of a 0.1 molar solution of iron 3 sulfate.
Oh, so they don't tell you. All right, yeah. So I see my notes here, or my key is I have to calculate the limiting. So again, you have to write out the equation. So there's 3 of that. Let's see, one of these, SO4 yields 3Ba SO4 plus 2 FeCl3. So you have 0.01 moles of both of these. Because of the information, they say 0.1 molarity and you have 100 milliliters of each. So that means you have this many moles of both of those. So now use your stoichiometry to get your limiting. I'm not going to go through that. You should know how to do that at this point. This is limiting. If you still can't take this, so if you know the balanced equation and you know the moles and you still right now can't figure out which one's limiting, that's okay. It's not the end of the world. You're not dumb. Okay? Some of this, it's just, there's a lot in your head here in this class. I get it. There's a lot going on. We go fast. So if you can't do it, please see me. We'll do practice problems and I'll help you figure it out so that you're confident moving forward. Because that's like a basic skill, whether you're in EP Chem or College Chem, you need to be able to do that. So if you can't do it still, it's all right. It's okay. People learn things at different speeds. So just come see me. So that's limiting. So now we're using this to calculate. This is what we're ultimately getting, right? Yeah, grams of this. Okay. So we use all of this. It's a 3-to-1 ratio, right? We have 0.01 moles of this. How many moles? Oh, wait. Wait. I'm sorry. Did I do that wrong? No, it's 3. So that's pointless. You don't even need to do it. This is how many moles of that will be produced. Because if this is limiting, all of it's used up. All of it's going to be found right here. in that barium, which is 0.01. So because it's a 1-to-1 ratio, we have 0.01 moles of BaSO4. So really this question, the hardest part was calculating who's the limiting, and then you just use this number multiplied by the molar mass to get grams. So 0.01 moles times 233 grams per mole, moles cancel, and we get 2.33. You know, this could be a multiple choice on an AP test because they're giving you 0.01 and 0.01, so those are numbers you can do in your head or on paper, and then even this calculation you can do in your head or on paper, right? Because 1 times 233 is 233, so you move the decimal 2 places to the left, and that's 2.33. So I just like to remind you, every chance I can, to remind you, this could be, you know, without a calculator, and here's how you do it. It's good to hear that, right? And just be aware of that. Okay, so that's that one. Question 3. All right, question 3. Nicole, can you read question 3 to me, please?
You're given a solid that is a mixture of Na2SO4 and
Yep.
0.205 gram sample of the mixture is dissolved in water in excess of the aqueous solution of BaCl2 is added. The BaSO4 that is formed is filtered, dried, and weighed. The mass is 0.298 grams.
Okay. Part A.
What is the mass of SO2 minus
Matt?
SO4 minus 2 ion?
Okay, mass of that, and then B, I want percent SO4
Yeah,
in the total mixture, in the original mixture.
in the sample.
Yeah, in sample. All right. So here's what's going on here. You have Na2SO4 plus K2SO4 reacting with BaCl2, and that makes BaSO4. That's what's happening here. This together is 0.20205. This is excess, and then we know we get 0.298 grams of this. All right, so we know the original mass of this mixture here. BaCl2 is added in excess, and then we get your BaSO4. So all of the SO4, so both of those SO4 ions, it's not both, but the SO4 from here, SO4 from here, both or all of that is right there. Okay, because this is excess, so these are completely precipitated. There's no SO4 floating around anymore. It's all on the precipitate. All right, so if we find moles of this, okay, then we can find the moles of each one because it's a 1-to-1 ratio. So moles of BaSO4 is moles of Ba and moles of SO4 minus 2. And then you multiply it by the molar mass. So let's see here. So if you take 0.298 grams, multiply by 1 mole over the molar mass. So I'm just going to do the inverse. The molar mass of BaSO4 is 233. So grams cancel. So this number is going to give me the moles of BaSO4, 0.001277 moles. That's a BaSO4. Since there's one SO4 and one Ba, that's the moles of both parts. So this is my moles of SO4 minus 2. Part A wants to know mass, so just use the molar mass. So 0.001277 moles times SO4 is 96? No. Yeah. 96 grams in 1 mole. Moles cancel, so my mass of SO4 is 0.1266 grams. Now I actually use 0.3 here. I'm just going quick, so it might be a little different. But that's your mass of SO4 minus 2. Now percent, all it is 0.1226 divided by the 0.205. So that's the total mass, part over whole, times 100, and it's about 60%. You get about 60% there. So I took anything pretty close to that. So if you didn't do well on that question, again, it's the concept, right? It's not the math. It's like, really, it's 3 simple math calculations. You guys can all do that. It's just the concept of what you're doing. You get the moles of your product, which tells you the moles of each ion, and then you can kind of essentially work backwards and say, all right, this is how many grams we started with. All right. Oh wait, was there a part? Oh no, that was it, right? A and B on that? Yeah?
Yes.
Okay. Go to 4. It would help if I had a copy of this quiz here.
How do you use stylus?
I think I already gave it back to her. Oh, it's right here. Hey. Not just a hat rack, huh?
No.
Meaning your head. It's not
Yeah.
just the whole hats. There's brains in there.
I got it.
Alright.
Don't worry.
Alright, 4. The answer is B. So this is taking a while, but that's all right. It's worth it. Because these are AP questions. M plus 1 unknown metal cation with a +1 charge. The student dissolves the chloride. Trevor, this is like a giant waste of your time. I want to get you a copy of this. I keep everything locked up like Fort Knox. You guys even know what that means when I say Fort Knox? Probably not. Huh?
Yeah.
You do? What's in Fort Knox? Gold. Yeah, our money used to be backed by gold. I don't think it is anymore.
Back by
Now it's now we just trade Bitcoin. I know. Here's a good idea. Let's just make up something that completely means nothing and use it as currency, and then it's worth a ton of money. How about I just make this piece of paper worth $2 billion, and then we just start trading paper? It is. It is. All right. Here you go. Don't mess this up. That's like the original. All right. Here we go. Yeah, my brother-in-law told me when he was in high school, him and his friends, or maybe early college, him and his friends were like, yeah, let's buy Bitcoin. Like they were joking about it because it was like so cheap, and he never did. Or no, he did, and then he sold it, and it's gone up like incredible amount. He would have made a lot of money off of that. But anyways, moving on. I still think it's ridiculous. Now, student dissolves the chloride in enough water to make 100 milliliters of solution. Student then mixes the solution with AgNO3 excess. Okay, so student collects the precipitate. All right, so it's very similar to the problem we just talked about here. Mass of the unknown chloride is 0.74. Mass of filter paper is 0.8. Mass of filter paper plus AgCl is 2.23. So first thing we got to do is subtract the 2.23 and the 0.8. All right. So we do that, we get 1.43 grams of AgCl. Okay. So what does that tell me? It tells me all the Cl that was in MCl is in AgCl, right? Because it said the AgNO3 is excess. So all of this Cl was in the original MCl. All right, now what is the identity of the metal chloride? So if we know the moles of AgCl, that is moles of Cl. And then you can work backwards because that's the same number of moles of MCl. All right. Moles of Cl, which is moles of MCl because it's a 1-to-1 ratio. So the way we do this, and the reason it's a multiple choice, no calculator, is if you add Ag plus Cl, you get 143. Right? There's 143 grams in 1 mole, so how many moles are in 1.43 grams? You don't really need to do the math. I mean, you don't need to set this up, because if this is in 1 and you move the decimal 2 to the left, what's X equal? How many moles do we have here? 0.01 moles of AgCl. So that's why I keep stressing this on how to just move decimal points, right? And they're not going to give you like 5 grams, and then you have to like do all this math. They're not going to do that. It's just moving decimals, all right? They could have given you half, maybe half of that number, and that would be 0.5 moles. So they'll do it so that you can obviously figure it out. So anyways, that is your moles of Cl, because there's 1 Cl in AgCl. Now, because it was excess AgNO3, all of your Cl here is right here. So I have 0.01 moles of Cl in MgCl, or MCl, sorry. MCl. So, and since there's a 1-to-1 ratio, it's not a 2 and it's not a, there's no subscripts, I have 0.01 moles of the entire thing. So that's huge, because now I know the mass. They gave me the mass, 0.74, and I know the moles. So 0.74 grams divided by 0.01 moles gives me the molar mass, okay, of MCl, and then I can add 35 to whatever metal it is, and that's how I figure it out. That's how I get my answer as B, which is K. So if you do 0.74 divided by 0.01, what do we get? 74? Yeah. Here's another way. If this stuff kind of like intimidates you and you're like, the decimals, I don't know how to do it, just get rid of all the decimals. So if you move this 1, 2, that's 74, go 1, 2, 74 divided by 1 is the same thing as 0.74 divided by 0.01. It's the same thing. So you get 74, and then 35 plus 39 for K is KCl, which is 74. That's a pretty classic AP question. There's a lot involved. You got to know what's going on there. And then, again, they give you numbers you can handle. Okay, so that's B. 5, which the answer is A. So which represents before it occurs, right? So the Mickey Mouse is water, right? The big one is oxygen, and the little 2 ears are hydrogen. So Ag plus is going to be attracted to the O's, and NO3 minus is attracted to the H. We did so many of those in Regents. Hopefully that makes sense. If you put D, you just weren't thinking about it. You guys should all know AgNO3 is very soluble, so it dissociates, breaks apart. So D doesn't make any sense. C is wrong because O is not attracted to NO3 minus. That would repel. Same thing with B. So they got it backwards in B. Okay, 6. During the course of the experiment, which of the following happens to the NO3 minus? The answer is D. They don't do anything. Dissolved into filtrate. Some kids might get it wrong because they're like, what is filtrate? Filtrate is just the solution that's left over after a reaction occurs. So like if you filter something, the solid stays on top, the filtrate goes through. Alright. 7. The answer is E. If you are, so gravimetrically just means pouring a solution with precipitate through filter paper and let gravity suck the filtrate out, the solution. So what causes problems? Well, if you don't mass the filter paper or the weighing paper, then you won't be able to actually get the mass of your product. I think everybody realized that. Let's see, what's 3 saying here? Oh, wash it. What does wash it mean? Rinse it with distilled water a few times to get any impurities or anything else that, basically impurity is the only word I can think of, that would go through the filter paper, right? So you want as clean as possible for purity, and then you're going to heat the AgCl to a constant mass. We put our precipitate from that lab, the first lab or second lab, in the oven, and that's what we did there. Now, technically you're supposed to heat these precipitates for a little bit till it's dry, mass it. Heat it again for a little bit, mass it again. If your 2 masses are the same, that means all the water was driven off. So that's what it means by constant. You're not supposed to just do it once. We did it once to save time, but that's how you're actually supposed to do it. All right, maybe I should stress that more when we actually do a lab, to at least do it twice so you see the reasoning. How come you don't need the temperature of the reaction? It has nothing to do with how much solid is produced. Okay, the temperature of the room or the reaction of the solution has really nothing to do with solubility rules. I mean, it does and it doesn't. Extreme changes would affect it, but that's not really going to affect. In a normal lab setting, the temperature isn't going to affect anything. Okay, number 8 is C. Now, I think a lot of you put D, and that's because of the sig fig issue here. Almost done. Stay with me here. I know it's tough to sit this 2 periods and listen to me here, or take a quiz too. So we're dissolving 60 grams of glucose in 180.2, in 250 milliliters, and the molar mass is 180. So what is that? Why do they give us the molar mass? What is that telling me? Molarity is moles over liters. So why are they giving me the molar mass? Why are they giving me the molar mass? well, yeah, so if 180, we're gonna round that to 180 grams are in 1 mole, we have 60 grams, so basically, it's going to be 60 divided by 180, right? So cancel those, 6 divided by 8, it's about 0.33, right? That's 33%. 3, it's 1/3. This is 1/3. That's another way to do it. This goes in 3 times. So that's how, again, you get around, you don't need a calculator. You just have to set it up like you would with a calculator, and then say, okay, how can I do this without using a calculator? So you cancel your zeros, 6 over 18, 1/3. So you have 0.333 repeating moles, right? Now, you have 4 sig figs in 60.0, and you have 4 sig figs in 180.2. So technically, this should be 0.1234. Right? So you round to the lowest number of sig figs. All right. Now, you take your moles and divide by 0.2500. Right? Yeah. So you have 4 sig figs here, 1, 2, 3, 4, 1, 2, 3, 4. So your answer should have 4. Your answer should have 4. And this is, again, how you get around the math. You may not be able to do that on paper or even in your head, but you should know that that's not 12. Right? That's not going to, how do we know for sure that's not going to be 12?
2 doesn't go.
Did someone put 12? Okay.
Yeah.
Okay, so let's play it out. Let's do each one here. So let's look at A and B. So if you do 25 times 12, right? Is that going to be, is that going to be a number that's like 300 or 333? No, in other words, this number is not 12 times larger than that number. So even if you were to do 25 times 2, think of this. 25 times 2 is 50. So if you move the decimal here, so I'm just trying to help, hopefully it's helping. If I make this 25, and that makes that 33, 25 times 2 is 50, so that's not 33, so 2 is too big. So dividing these is going to be less than 2, because multiplying that by 2 is still bigger than that number. Does that make some sense, what I'm trying to show you there? Again, this is how I literally do this myself. I get rid of the actual decimals and I start moving them so I get bigger numbers, and that's just easier for me to handle. If you can just straight up look at it and do it, good for you. All right, whatever it takes. So now I know A and B is wrong. And now I look at C, D, and E, and I'm like, they're all the same answer. What the heck? So now I go back and I look at the significant figures. Did it say anything about sig figs? No. That's the part that frustrates me with this question. I feel like they should tell the kids, pay attention to significant figures or something like that. They're kind of just throwing that in there. Now kids are like, well, is it 1 or is it C or D? I don't know. So it's got to be C. Even if you can't do the math, it's got to be, they're all the same answer. It's got to be C because of the 4 sig figs. 1.332. That's not an easy problem. That's a hard problem. I bet a lot of kids got that wrong whenever this was. I forget what year that question was. So if you got it wrong, don't feel bad. All right? That's a hard one. 9. All right, number 9, the answer is E. Let's see, you have 0.2 moles of MgCl2 and 0.1 of KCl dissolved in water and diluted to 500. What is the concentration of Cl minus? So what you need to do is find the moles of Cl in each compound, add them together, divide by 0.5, right? So if I have 0.20 moles of KCl, nope, sorry. I really wish Skylar was here, but if she's watching, pay attention, Skylar. This is what you were telling me you have trouble with here. 0.10 moles of KCl. This is the same number of moles of Cl. So here we have 0.01 moles in this. This we have to double because there's 2 of them. 1 mole of Mg, so 0.2 moles of Mg is present, but we double it because there's 2 of them, so it's 0.04 moles of Cl minus here. I don't know why I wrote it differently, but we have 0.01 and 0.4. No. Sorry. 0.1. Sorry. 0.1 moles of Cl minus here and 0.4 here. So that's 0.5 moles divided by 0.5 liters, which is a molarity of 1. They gave us the volume, we just have to add that up. All right, and that's why it was E. And it's 1.0. I didn't keep my sig figs. There's 2 here, 2 here, and there's 3 here, but 2 is the low, so 1.0. pretty classic AP question. You should be able to do that. If you didn't, again, I'm not trying to make you feel bad, but like 8, okay, that I can see people getting it wrong. 9, you guys should be able to do. 10, last one. And then do we have time to do anything? A little bit. All right, 10, the answer is A. Let's see. You have 50 milliliters of 1, so 50 milliliters of NaOH, and the molarity is 1.0. It's diluted with water to a volume of 2. All right, so if it's 1 and it's 50 equals X over 2. All right, now wait, that can't work. It can't be 50. It's got to be 0.05 because you got to have the same units. Or what you could do is 1 times 50 equals X times 2,000. You can do that too. That might be easier because then if you do that, it's 1, 2, 3. Again, this is what I do. I'll get rid of decimals as much as I can. Get rid of decimals. I'll do it. So 2,000 divided by 50 cancel out the zeros. 200 divided by 5. What did I do wrong?
Other way around.
Oh, right. I'm like, that doesn't make sense. X. So 50 divided by 2,000. All right. So it's 5 divided by 200. And again, if we get rid of the 200 and 5 divided by 20, how does that help? That helps me. How many times does 5 go into 20? Of course, this is 1/4. So what do we? So that leaves us with A, because if this is 0.25, but really it's 200, you have to move the decimal. It's 1 decimal place smaller, right? If this is 0.25 of this, then this, the same number here, but this is 1 decimal bigger. It's 0.025 because you're making that 1 decimal place bigger. So that's your molarity, 0.025. Again, the way I explain it is how I literally do it myself if I was taking it, and how I would think about it. Doesn't mean that's the way you want to do it, but I'm just trying to help with without using a calculator. All right. So you guys are doing a good job. I know it feels like we're in here forever here. That was good. I wanted to go over that. We're done with that. All right. We only have like 6 minutes, 7 minutes. Problem set number 3. Questions for me? Yep. She came in yesterday and worked on the whiteboard. If anybody wants to come in and work on the problem set, you can do that. Giving you a chance to get help. No one's asking questions. So that means everyone's going to get 100 on this thing?
Oh, no.
Right. So what's the questions?
Not you.
No one has questions.
No.
Use your time wisely.
These are a lot of problems.
Yep.
Like, a lot.
I told you when I gave it out to you, don't wait till...
Is number 1 supposed to be easy, or am I just not
I
saying
it's
it?
not.
It's
It's
not.
It's not easy.
You're supposed to write out
Yeah.
the.
I'll give everybody a hint, even though you're not asking, because a lot of you are going to get one wrong, unless you talk to Nicole. You don't have to use all, 1 liter they give you? You don't have to use all of the volume. You have to use all of 10.1. So what did I suggest for you? Use 500 milliliters? Use half the volume and dissolve all 10.1 grams in 500 milliliters. And then that's your first solution. Then dilute that one. That's a huge hint. So that's how you do number 1. Okay. No other questions?
Well, it's to like lay out the step by step.
Right, so yeah, Chi Chi was confused about this. Once you do the calculations and get the numbers, so I know I need this much of this solution with this much water, and so you know the numbers, then you have to write a sentence or two as if you were actually going to make the solution on a lab table or in the lab. So I'm going to take this, I'm going to measure this out, I'm going to pour it in here, I'm going to add this. You have to explain how you would make it. If I gave you the equipment and you had all that, how would you actually make it? So I need numbers and like words, explanations. both. Any other questions on the problem set? I could probably turn this off. You guys